This is episode 1 of a series I'm calling Charming Python, in which we will take a random assemblage of Python scripts that are useful but, not particularly well designed, and add a certain level of sophistication to them to get them to the point where they could be something that you could maybe call a research platform. We're going to add tooling, we're going to add testing, we're going to add a lot of automation, and we're going to sort of whip these things into shape. To start with, let's talk about what this thing is. This is a script that I wrote to simulate putting. This whole repository here is my golf repository. If you want to check this out for yourself, you can go to github.com, benrady/golf, and see what I've been screwing around with here. It's basically like simulators for golf because I'm a giant golf nerd, but this is the exact perfect kind of thing for cleaning up and turning into something that is going to be intersubjective. What is intersubjective? What is this word? Well, it's really important. I have seen this at my current job working at Quada Capital Management, working at other places, that when you build software, specifically or in particular for research, but really anything, when you build software, you need to make sure that the process that you use to interact with that software is reproducible. You can think of this almost like this concept of intersubjectivity is almost a little bit like a recipe. In some ways, it's sort of the basis for all science. But if I say, okay, here's the recipe for a BLT, bacon, lettuce, and tomato sandwich, you get some good wheat bread, you get some bacon, you cook the bacon in an oven at 400 degrees for 20 minutes. You should always cook your bacon in an oven, by the way. You get the lettuce, you wash the lettuce, you slice the tomatoes into nice thin slices, you get some homemade mayonnaise, you put the mayonnaise on the bread, you put on the bacon, and then the tomatoes, and then the lettuce, and then the other piece of bread. You cut it in half, and there's your bacon, lettuce, and tomato sandwich. I can give you that series of instructions, and you can make a sandwich, and you can, from your own subjective point of view, experience the same thing that I experience. You can reproduce my sandwich making results. And when we're working in software, we have this amazing advantage of being able to automate many of these things. And so the first step, what we're going to do in episode 1 today, is we're going to get a reproducible intersubjective Python environment set up for these scripts so that we can run them using a version of Python that we can be confident in, and with the dependencies that we can be confident in. And we're going to do this in a way where the installation of all these tools is completely automated so that anyone who wants to reproduce our results or work on this project can simply clone the repository, run a few basic commands, and voila, everything is set up for them exactly the same way that it's set up for everyone else. So we don't have this terrible experience of, oh, I ran it and I got these results, and you ran it, you got different results. Why? I don't know. Let's troubleshoot the 35,000 different things it could be. We're trying to avoid that. So to get started, we're going to open up an editor, and that editor is going to be PyCharm. We're going to use PyCharm Community Edition to do this. It's freely available to anyone that wants to use it. And so it makes sort of a great tool for this. PyCharm is trying to do a whole bunch of things for us right now. We're going to, I don't know, download some indexes, and it's picked an interpreter. We're going to have to change that. But we are going to open this up and use this as our editor. The very first thing that we're going to do here is we are going to make a file. We are going to make a makefile. So what's a makefile? Well, a makefile is a file that you use with a tool called make. Make is something that is pretty much universally available on most operating systems that you would use for software development, OS 10, Linux. The trick in doing this, again, what we're trying to do is create this intersubjective environment where all the tools and all the dependencies and everything that you need to run our software to reproduce our results is installed automatically and consistently. And so one of the tricks in that is, okay, well, what tools do you use to install the tools, and how do you make sure that you are doing things in a way that is both consistent and also efficient. Like, we don't want to reinstall the tools the same time over and over again. There's lots of different ways to do this. You can do this with shell scripts. You can do this with other sort of build and installation tools. I really like using make. Make is a tool that I think falls into the category of boring is awesome. It's been around for a very long time. It's, again, sort of ubiquitous. It's available on pretty much any machine that you would want to use. And once you sort of get the hang of it, it is really useful. It's really great at optionally resolving a tree of dependent tasks, which is kind of what we're doing when we do these kinds of things. So we're going to start with make. Okay, so how does make work? Well, you make this file called a makefile, and in the makefile, you put targets. What are targets? Targets are either the names of files that you want make to create for you, or you can make what's called phony targets, which are targets that are not actually the names of files. They're just words like run or test that you want to be able to have make run for you and resolve all the things that it's going to resolve. So what we're going to do is we're going to make a make file that's got all the targets in it that we need to install and configure our Python runtime environment. We don't want to use the system Python to run our code because that's going to make it very hard to make the experience intersubjective. The exact code that we'd be running would be a function of whatever happened to be installed on the operating system at the time, which might vary from computer to computer. We want to create our own isolated Python environment that is just for this project. We want to have total control over it. We want to be able to install and uninstall whatever packages we want, and we want to be able to build a lot of automation around that to make it consistent. If we did that with the operating system's installation of Python, we might break some things, so we're not going to do that. So to get started here, I'm going to make a target that I'm going to call deps. And this is going to be short for dependencies. And what this target is going to do is it's going to install our dependencies for us. So the most basic thing that you can do with make is specify targets that are the names of files. So I'm going to make this target here that depends on another target called Python. So the way that you represent dependencies in a make target is you say this is the name of the target followed by a colon, and then all of the dependent targets come after that. So I need another target up here called Python, and you might be looking at this going, what is the deal with the $sign and the parentheses? Well, what that is that's a variable. So when I want to run this thing right here, and I can even just throw a couple of bash commands in here just to show you what's happening. Hello world, do the classic hello world. If I go back down to my terminal and I run make deps, I should see hello world. Cool, and I do. And one of the things that make will do by default is it will print out the commands that it's running. So I'm actually going to temporarily suppress that just to cut down a little bit on the noise. We will probably take this out later because this is a really useful thing to have. But if I add this little silent, fake target at the top and I run this again, you can see that is now suppressed and we're just printing out our hello world. So that's coming from this. So what's happening here is we run make deps, looks at this and says, oh, there's the deps target. I'm going to run that. It depends on Python, which currently is like undefined and does nothing, so nothing happens there. And then it runs these commands that are underneath the target. So that's basically what's going on with make. So let's talk about these variables. Variables in make are really useful. They can be set inside the make file. They can be set at the command line. What we're going to do is we're going to create a tree of dependencies that go from running our program to getting Python, getting a Python virtual environment, to creating that Python virtual environment using Conda. And the great thing that make is going to do for us here is optionally resolve all of those steps if and only if they need to be done. So we're going to try to run Python. Oh, Python doesn't exist. I need to install it. How do I install it? Well, I create a virtual environment. Well, how do I do that? Well, I use Miniconda to create a virtual environment. Well, how do I get Miniconda? Well, I need to install Miniconda. All those steps are going to be taken care of for us in just like about 20 lines of makefile. It's going to be brilliant. So to do this, I need to define this target. And again, in make, the two basic, I mean, there's a few different ways to use make, but the two basic kind of targets that you can have are the files, so like the names of files. In this case, like this is the Python executable that we want to exist that does not exist yet. So we're trying to tell make how to do that. And the sort of phony targets, which you need to specify. So I'm going to say that deps is a phony target. Cool. All right. So Python here is going to be the path to our Python executable. How are we going to define that? Well, we're going to define it as the root directory of our virtual environment /bin/Python. That's usually in a Python virtual environment where the Python lives. Okay, what the heck is venv? What is this venv variable? Well, that's just another variable. We're going to define one of those, and we're going to say that venv is equal to curdir /venv. So this is a .venv. So this is a directory within the current directory. This curdir variable here is a built-in make variable that says whatever the directory of the make file is. So in our case, it's the root of the golf repository that we have cloned. So our virtual environment should be a directory that's going to be a subdirectory of this root directory here. And Python is going to live. Our Python executable is going to live inside of that virtual environment directory in the bin directory right here in this Python location. So if I run this now, what's going to happen is make is going to look at this and go, none of these things exist. I don't know how to create this. So I'm going to throw a little echo in here just so you can see it. Installing Python 2, and then I'm going to do the little Python thing right here. So this is make saying like, you want this file to exist. It doesn't exist. You need to make it. The way you make it is by running these commands. So if I do this, it's going to say installing Python to this directory, and you can see the full path here of where this is going to get installed to. Now, obviously, it's not doing that yet, but that's what we're going to make happen next. How are we going to do that? Well, we're going to do that by using a tool called miniconda. Conda is a package management and sort of virtual environment management tool that is very common in Python. You may have heard of it before. There's a sort of lightweight installation of it called miniconda, and we are going to use miniconda to create our virtual environment. But again, we don't want to install miniconda into the operating system because that we don't have as much control over that environment. So we're going to install our own version of miniconda into this project for the purposes of managing the environment. So just like we did with the Python executable, we're going to create another target for the conda executable. And just like we did with the deps target, we're going to make our Python target depend on conda. So we're going to need conda to do this, right? And so the way that we install conda is by following the installation instructions for miniconda, which I will not bore you too much with, other than to say we fetch a shell script using curl like that. We are going to write it into a file in the current directory called miniconda.sh. We're going to remember to clean up miniconda.sh after we run. If it succeeds. If it doesn't succeed, I kind of want to look at what that file was. Maybe there was something wrong with it. And then we're going to run that command with bash. So, you know, the classic, let's all exploit our computers by randomly downloading bash scripts from the internet and running them without looking at them. Miniconda.sh. So normally when you run this, it will prompt you for a whole bunch of options, like where you want to install it. We don't want to do that. We want to automate all these things. So I'm going to use a couple of different options here on the command line to miniconda to say what I want is to install it to a miniconda directory. Guess what? We have another variable, miniconda. So we're going to go define that. Miniconda is going to be equal to our old friend curdir again, followed by miniconda3. Yes, so like that. Cool. So we're downloading our installation script. We're going to run that script, telling it not to prompt us for any information and say, hey, I need you to install this to this specific directory. And then we're going to clean up the script after we're done. So that is going to provide us a conda binary which is going to live, whoa, I haven't defined that yet. I need to define that. That conda binary is going to live inside of our mini conda directory in, perhaps not surprisingly, bin conda. And then that conda binary is what we're going to use to install Python. How are we going to do that? We're going to use I might just leave that echo in there. That's kind of a nice thing to have. We're going to say conda env create. That's how you create a new virtual environment with conda, or one of the ways anyway. And we're going to give it the location of the virtual environment that we want it to create. So we're going to say, hey, this is how you do that. So yeah, so just to summarize here, deps depends on Python, Python depends on conda, conda is installed via curl and running this bash script. And now, hopefully, if I've done this in the very first take, we can run make deps here, and it will install some stuff. All right, looks like it's installing. Through the magic of video, I might fast forward through some of this because it takes a long time. Cool. All right. So actually, I didn't have to fast forward at all. So it went to install environment and saw that we didn't have an environment file. That's perfect. That's exactly what we want to see. So it installed miniconda, and you can see if I come up here, now we have this miniconda directory that is showing up in our repository. I'm actually going to go into IntelliJ or PyCharm here and exclude that because I don't want it to go indexing all those files. And so it's automatically created this. So the next thing I need to do is actually go and tell Conda which packages, which Python packages I want to install into my custom environment. So I'm going to say, I'm going to make a file called environment.yaml. And yeah, we can add that to Git. That's fine. And then we're going to go and make a Conda environment file. And there's plenty of resources on the internet you can find for how to do this. I'm just gonna sort of blaze through this right here and say, all right, I'm gonna have this environment called golf, and I'm gonna install dependencies from a couple of channels. I'm gonna install from CondaForage, and I'm gonna use the defaults. And then for my actual dependencies, I'm just gonna start off with IPython, and I'm not even going to specify the versions yet. We're going to talk in a later video about one of the really important things that you need to do to create intersubjective research environments is specifying the versions of the dependencies that you use and their transitive dependencies. And so it's really important to make sure, if you want reproducible results, that when you run a Python program that's part of your tooling, part of your research platform, that the other people that are running it are using the exact same versions that you are. This is part of the reason why we're isolating ourselves from the system environment, is to be able to lock this down. If we don't specify the versions, then we don't really get that benefit. We're going to come back to that in a second video on how to do that. But for now, just sort of recognize that adding a dependency here with no version information locking is not something that's not the end state that we want to be in. But to avoid shaving all the axe all at once, we're gonna just add this in. So if I add this here and I save it and I run my deps again, it's not going to reinstall miniconda. Make has looked at this and determined that it's like, no, you've already got conda. I don't need to install that again. But what it is going to do is it's going to install our virtual environment. So now it's creating the virtual environment for us and installing it to that VM directory that we specified here. So maybe a little bit of magical video fast forwarding. Cool. All right. So we now have a virtual environment that's been installed automatically. If I run this again, you'll see that it just immediately runs. It doesn't reinstall it, which is great. So it's only doing the work that needs to be done. This is perfect. So let's talk about what files we actually have in our repository. As I was saying before, this is sort of a random assemblage of scripts. And now that I have a virtual environment that I can trust, I can run this by just calling the Python here and saying like, oh, let's look at this like stimp meter file. What does this do? Cool. All right, usage. It says, all right, I'm going to give it a slope, and I'm going to give it a speed, and I'm optionally going to give it an initial speed in inches per second. So if I do like, a slope of 2% and a speed of 10 stimp, it prints out some stuff. Cool. All right, so that's great. So I can automate that if I want to in make. Now this isn't a super useful target as is, but just as an example, I can say that my run target depends on deps, and I can reference the Python executable that I know is installed, because at this point, if I run this target, Make's going to go, oh, well, that depends on deps. Deps depend on Python. Python depends on conda. And it's going to make sure that all those things are installed. So I've got a Python executable here that I know I can use safely. And I'm going to say stimp meter.py. And I'm going to pass it some arguments. And now if I come down here and I do make run, we get the same result. Great. It's printing out this hello world here because this is part of deps, but we don't actually need that. We could get rid of that if we wanted to. Rerun that again, and you can see that you get the same result. Cool. So now this will, let's say, this is probably a good time to commit this. So let's add our make file and our environment file, and we'll probably add some get-ignore stuff here for mini conda 3 and for venv. Cool. So now we have sort of the basics of a reproducible environment. Yeah, I know I'm old school and I use git on the command line when I could be using it through PyCharm, but I'm not. All right, so now we have basic venv installation, right? So we got that going on, which is cool. Great. All right. So we've got it. We've got the basics here. We can sort of install and run, and that's cool. Now, one more thing I'm going to do here, just to make my life a little bit easier. This is a trick that I have used for a while when using make files. We do this at Aquatic. We do this in a bunch of places. When you run make by itself, the default behavior is to run the very first target. Now, the very first target in this case is conda, which is going to do nothing. So I'm going to make that be a little bit more useful, and I'm going to add a target called help. So if you run make help, you will get this. But if you just run make, it will tell you what it'll run the help. Now, what is this help command? It looks like, grep followed by a bunch of cartoon characters swearing, followed by a bunch of magic other things. What this is doing is it's grepping through the make file itself to look for a special kind of comment, and it builds this nice little sort of help menu out of that. This is just a neat little trick that I picked up a while ago, and we're going to copy that here. So the way this works is you add a comment with this sort of double hash, and you say, run the stimp meter example. And then this can be something like install dependencies, if you can spell dependencies correctly. And now if I come down here and I run make, I get this nice little menu that says, oh, here are the targets I can run. I can run make run. I can run make deps, which is not going to do anything because all the deps are installed. And it sort of tells me what my available commands are, which is really nice. So we got that in there. Maybe do another commit for that. Adding help target. It's really important when you're doing this kind of work to work in very small steps. You'll see me committing quite frequently. Whenever you're sort of in this state where you don't have the right kind of testing in place, you don't have the right kind of infrastructure in place, it's easy to make mistakes. The reason that we build that infrastructure is to prevent mistakes. Cars have brakes so you can drive faster, right? So what we're trying to do is work when we're in this state where we don't have these things yet. We need to work in very small steps, because if we encounter a problem, we want to be able to limit the scope of our search to only the things that we've changed recently. If we change like 35 things at once and then we notice a problem, it's like, okay, well, one of the 35 things that I changed caused this problem, so I guess I need to sort through all of them and figure out which one it is. Much easier world to live in if it's like, well, I just introduced a bug, I've only changed one thing, so it's probably that one thing. So we want to work in very small steps in general, but in particular when we're in this environment or in this situation where we don't have all the infrastructure that we would want. All right, so next what we're going to do is we're going to take a look at our environment file, and we're going to think about a particular scenario. So this whole makefile setup is nice, it's very useful, but it has some limitations. And one of the limitations right now, which we want to try to address, is rebuilding our environment. So if I come in here and I come into my environment.yaml and I want to add a new dependency. So I want a new library that I want to depend on. Let's just say PyTest, because we're going to want to add some tests. And I run my make run again. It just runs it. So this environment now doesn't have PyTest in it, even though I changed this file. So what I want to do is change my make file so that the make file actually recognizes when the dependencies have changed and installs them for me automatically. This is just a way to make sure that, again, trying to, as much as possible, create a consistent environment, create an intersubjective environment where I can be confident that if I run a command or if I do some other sort of task, that I'm doing it the same way that everybody else is doing it. So the way that I'm going to do that is I'm going to change my deps target. I'm going to create. I've got this phony deps target here, which is sort of nice. It shows up in our make menu, and I want to leave that like that. But I'm going to make another target, and I'm going to call that one. Maybe I'll call it environment. And what this environment is going to do is it's going to depend on Python, but it's also going to depend on our environment.yaml file. So what that means from Make's point of view is that it's going to look at the modification times of these various things to try to figure out if the targets are out of date. So when running this environment target, it's gonna look at Python, and it's gonna look at the environment.yaml file to try to figure out, like, okay, are the dependencies newer than the target? If the dependencies are newer than the target, that means they've changed, and I need to run this target. If they're older, then I don't. So it's sort of Make's mechanism for trying to determine whether or not its targets are out of date, which is kind of simplistic, but it works most of the time. So I added this new variable here. What is this thing? We have to define what that is. And what I'm going to say here is that environment. Oops, I don't like that. Nope. Environment is a file that we're just going to sort of synthetically create inside of the virtual environment that's just a copy of the environment.yaml file. And the reason I'm doing that is to say I want to use that as sort of like a little bit of a flag to say, hey, if the virtual environment that I've created and put in the vems directory is older than the environment.yaml that lives in the root of the repository, then we probably need to rebuild it. So that's going to be a two-step process. The first is to use conda to update our environment. So we're going to say env update. We're going to prune old dependencies that we don't have anymore. We're going to make it quiet so that it's not dumping a bunch of stuff out into the console. And we're going to tell it the location of our virtual environment, and we're going to tell it the location of our environment. Oh, God. Environment YAML. Cool. So that's there. And then the second thing that we're going to do is we're going to copy the environment YAML into the, we're basically going to copy it to this location here, to this environment location here. So we're going to copy this to that. So what this is doing, maybe back up a step here and talk about make again. So fundamentally, again, targets in make are either the names of files that you want to exist or synthetic phony targets that you make just, for sort of convenience sake. In this case, this is a file we want to exist. The file lives in venv/environment.yaml. To create it, basically what we're doing is copying it, right? So our creation process is take this file and copy it into this directory, right? But along the way, we're going to have conda update the environment when we do that. So we're sort of giving make a little bit of a hint to say, okay, the way that you can tell if this whole virtual environment directory is out of date is by comparing the file that's in this directory to the file that's here. And if it's older, then it's time to update it. So right now, this doesn't exist at all. So my expectation would be if I run make deps and we've done this correctly, nothing happens. All right, nothing new ever works. What do we do wrong here? So environment. Oh, right. Deps doesn't depend on environment. That's what we need to do. Okay. Let's try this again. Hey, look at that. Okay, so now it's going to look at this and say, oh, you depend on the environment file. The environment file doesn't exist. I need to create it. So the way I'm going to create it is by running these commands. it's going to update our environment. Nothing should really change because we haven't changed our YAML file. Oh no, I did add PyTest there actually. Yeah, yeah, that's good. That's good. So now we've got PyTest in there, and it has hopefully gone and created something, something, something. Then, yes, you can see here it's now created this environment file. We've copied the environment file into here. If I were to do this again, it does nothing because it's up to date. If I were to go and change this and take PyTest out and then run make deps again, it resolves the environment. In this case, we'd be removing PyTest from the environment, which is what we would want. So that's cool. So now we can depend on this target for any other thing that we do. So if we want to run tests, if we want to run Jupyter, if we want to run anything in our research environment and we want to make sure our dependencies are up to date, and why wouldn't you want to make sure your dependencies are up to date, then we can just have the targets that do that depend on this deps target, and that will ensure that the dependencies are always up to date. Okay, so now we have sort of a basic environment here for working with Python. Let's do one more commit to add our changes here, add our new environment. So checking for changes in the environment.yaml in makefile. Cool. All right. And so yeah, so we have our environment here that is being entirely maintained through make. And the only things that you need to make this work, you clone the repository, you have a computer with make and curl installed, and bash, but I mean, if you don't have bash, then what are you doing? And these are things that are very commonly available in most Linux distributions. So it's a pretty lightweight set of requirements for people. But you can clone the repository. You can run these commands. You can run clone the repository, run make. See, oh, these are the things I can do, and it will install all the dependencies for you if you do those things. Cool. All right. So this is part one. We've set up our environment. We've automated the creation and installation of the tools that we need. We've got a mechanism for specifying dependencies. In the next video, we're going to talk a little bit about testing, and we're going to talk about how to set up a basic testing environment, just being able to run tests. That should hopefully be coming up in the very next video in this playlist, which hopefully you have queued up, and that will be our next video.